Okay. So, so like I was saying, yesterday we went over strings and over the methods that we had, and really look at some good tips and tricks when dealing with that data type. Today we're going to go over lists and tuples, which are, just like a string or a collection, just you can have different data types in that collection. So there's a bit of difference. And of course, the biggest difference between strings and lists is, lists are mutable, so you can change them in place. So that is a big difference between strings and lists. But a lot of the behavior, though, because they're both collections, still mirror each other otherwise. So let me go ahead and start sharing my screen, and we can dive right in. As far as the exercises last night, I'll wait till the end of this lesson to kind of go over those. If anybody has any questions, we can go over the results of some of the exercises that we had put into the GitHub. The exercises for tonight's lesson are down at the bottom of that file for lists and tuples in that markdown file. So you feel free to go and access those Replit links and fork them over to your profile and start working on it. Let's see here. Share screen. Okay, can everybody see my screen? Perfect. Okay. So yeah, today we're going to go over lists and tuples. And lists are a pretty fundamental data structure in Python. You're going to find yourself using lists quite often because they're good for storing collections of items, and they're good for like using in conjunction with for loops. So if you're using a for loop, you'll probably be looping over some sort of list, but you could be looping over other types of collections. But a lot of times we use lists as like little collection bins for things that we're searching for with a loop or some sort of condition that we want to save some data from that bigger collection. We will use a list to kind of hold those. And so we'll go over the capabilities and limitations, and then kind of understand the concepts of mutable versus immutable, because lists and tuples, that's one of the big differences between the two. Lists are mutable and tuples are not. So we're going to spend majority of the time, I would say majority of the time for this session on lists, because lists behave a lot like tuples outside of the things I just mentioned. And some of the methods that we have for lists will not apply to tuples, and so on and so forth. So yeah, we'll go over those two, and then we'll go to the conclusion and the exercises. So I'm thinking this will probably be I don't know, maybe the same length as yesterday. It depends on how many examples we get into. We'll see how it goes. So the first off with lists, if you notice, I have kind of my first cell here on my Jupyter notebook. I kind of already put in just a couple things. I made two variables, and these two variables are both going to be empty lists when I run this cell. Because this is both the ways you can instantiate an empty list. You can either call the list function in Python, which is nice. This just kind of tells you what it is. It's a class list. If no argument is given, this constructor will just create a new empty list. So if I run this and I print both of these, print my list and my other list. If I go ahead and print that, you'll see I get two empty lists here in the output, and that's exactly what they are. We know that lists are ordered collections of items, so when we assign items to a list, they will maintain the same order as long as that list exists. So once it's assigned in memory, the list will not change the order of the items in the list unless you change it. There are operations that we can use to change the order of a list, to add new ones, to take some out. So they're ordered, and they're going to maintain that order throughout their life cycle. And they're created using those square brackets like I illustrated there. And so again, this markdown file will have some good examples. They'll be pretty simple. You know, we typically do the list of numbers to show an example of a list. But remember, lists can hold lots of things, not just numbers. They can hold strings. They can hold dictionaries. They can hold more lists. You can have lists nested in lists. They can hold floats. Any type of data you can hold in a list. So to illustrate that, I can say, I'll just redefine my list. And that equals, I can open it with list, and I can put a 1. I can then put in a string. I can then put another list. I can put a set. So I can, oops. And that is completely acceptable. And I can then go ahead and just put it in the output so we can see it. I can run it. And there we have it. It exists as this list full of all these different data types. It is nice. And you can add, remove, and modify those elements as needed. And that's where we get into the mutability. So lists, this is the difference between lists and strings, the fact that lists can be changed in place. And I can do that with simple bracket notation. So I can add an element by using the append method. I can just I can use the remove method to remove an item in the list. And when I do that, I change it in place. And that can cause some issues when you're looping over a list. And I'm sure one of you is going to run into that issue on maybe some of the exercises or future exercises that you do when you're dealing with lists. But I can just say, okay, well, I'm going to go ahead and add an item to the list. I can just do the append method, and I can add in, let's just add in a float. So I can say 2.3. Let's go ahead and do a print statement here. And then print it again so we can see what happened. All right. So there we go. I have my list. I printed it, and then I appended an item, and I got my list back. I didn't redefine my list like I do with a string. I actually changed it in place with new data. And that's the mutability. And that's where we can add, remove, or modify elements. So I can go even further and say, well, my list, I didn't mean to put 2.3 in there. I really meant to put 2 or 3.3. Okay, and I can print it again. Okay, and so what happened was I defined my list again. So I reran this entire cell. So I just, redefined my list as this initial list, and I printed it. And then I appended 2.3, printed it again, and then I changed the last element in place to 3.3, and I printed it again. And remember this indexing, we learned this with strings. When you use those square brackets and put that index in there, I just shared the graphic on our Slack channel with the sequencing, showing those indexes, both the positive indexing and the negative indexing. If you want to go to the end of a list, you can use the negative indexing, and that's what I did. I accessed that last item in the list, this 2.3, and I just changed it in place to a 3.3. And so that's how you do that. So you just redefine it using the indexing.
So Aaron, you didn't. So if you're changing the last character there, why wouldn't it still be 3.3? You're changing the 0.3 to 0.3 if you use -1, aren't you?
Well, no. So I'm not changing. So you can't access like indexes of a float, right? I'm not changing just this or just this. I'm changing the whole thing. So I'm changing this right here is the -1 index of my list, because this is one item, this is one item, this is one item, this is one item, and this is one item. You see these commas that are separating each data? I know there's more stuff in here because this is a nested list. So in the context of the main list, my list, this inner list is just one item. Then I can go into this inner list and then separate those other items. And I can show that in this lesson, but we actually have a whole dedicated lesson on like two-dimensional lists, which is the nested lists, and what you can do with them and what they really illustrate. But for now, just know that when I'm talking about in the context of my list, and that's the only thing I'm changing here by appending and accessing indexes of and changing things, I'm in the context of this main listing, which contains 5 items. So I can even do len my list, and I can run that, and it shows that I have 5 items here. Even though there's a lot more than 5 items in the whole like list when you go into the nested portions. Each one of these is an item though, so that's an item and that's an item. Do you understand that? Does that make sense?
Yeah, I got it. 2.3 is one item to itself. Got it.
Yep. And then when I access the -1, I'm just redefining it. I'm just changing it in place right there. So again, I'm not redefining the entire list. I'm just redefining that one element in the list. So. All right. So some of the other things we can do with lists, which I just showed one of them, I use the len function on the list to get the length, and that will just give you how many elements are in the list. If I wanted to access how many elements are in this nested list, I could do that. And I can just do that by accessing that one element. So if I take a look at the list here, I have what index is this again? If I were to access this one, what?
0.
0, right? So I need to go 0, 1, 2. So if I did the length of list at the index of 2, and I ran that, I'll get a length of 3, because then I'm actually drilling down into this item. So I'm getting the length of that. But the length of my list as a whole is 5. You can check for membership in a list. So you can basically say something like, here in the example, we have like 2 in numbers. You can make like a Boolean statement to see if you have a member that matches what you're checking for. In this case, we have an A in there, so I can say I can do something like that, and I'll get a true statement because I do have an A in the list. And this kind of, just to give a, bit on the review of one of the exercises, because you can also do something kind of the same way, not using in, but you can check for those like DNA sequences using kind of this method of looking for a certain character in a list or in a string. So that's just something to keep in mind. Okay. We can continue using my list for this, but so I've already kind of shown you append. So we can, this is one of the methods we can use to add an item to a listing by using append. And we can also remove. So I can just do my list dot remove, And I will go ahead and remove A. And I can then call my list again. Run that. And you see that the only string in there that was removed. I'm gonna run it again up here. And then let's try and do lowercase a. When you try and remove something that is not there, you'll get a value error and say that, whatever, it'll say list remove X, and they'll say X is not in the list. What this means is this saying, hey, whatever you're asking for, they're using X to stand for that. Whatever you're trying to remove is not in there, so you'll get an error. So that's something that you'll need to watch out for, because this is a Python error. If you see that, it gives you an error and it says a traceback, this kind of error stops your program. So if you're trying to find something in a list, but it's not there, you want to kind of introduce some logic that will not stop the program. And there's ways to do that. They're a bit outside the scope of this lesson. So the exercises you have, I don't think you'll have to worry about doing that. But just know that you'll have to kind of introduce some logic to prevent yourself from getting error. So just keep that in mind. This kind of error will just stop the program and it won't run. And sometimes you can pull your hair out if you're trying to do something and you're like, I don't even know what to search for. I'm trying to search for one thing, but if it's on there, like how do I stop it from ending the program? I want to keep it going. So just keep that in mind. Any questions on what we've gone over so far? Just with the appending and the removing, accessing elements, changing elements. Great, the chat's pretty quiet. That's good. We can just keep on pressing. The next method we have here is sort. I think we kind of go over here. So I'm already kind of covering some of the ones we're going to talk about. And for this one, I think I'm going to go ahead and make I'm going to clear all the outputs. I'm going to make a new list here. So let's do list equals okay, we can do that. So we have a list of some characters, and we even have a number in there. So we have an integer in there, and then we have some string characters. New list sort. Let me go ahead and print. Oop. Okay, so I'll need to make this a string. Let's just go ahead and make it a string. Try and do that. Okay. That's my new list sort. I think I'll have to do it like this. I may have to actually assign it to a variable. Yeah, I'm going to have to assign it to a variable. Sorted list equals, there we go. Then I can call that. Try and do that. Oh, okay. All right, so this is one of the things I was going to talk about, but I guess we can talk about it now because I kind of forgot that this one doesn't return anything. So when you have a list that you want to sort, and what I was doing, I was trying to get it in sorted order. The new list.sort, and I'm just going to pull it up. Actually, that's probably better to do. That way we can look at the difference. Um, so Python. We can go here. Aha. Okay. Yep. Okay. So I need to just do that and this. All right. There we go. Okay, so what happened was when I had this list, right, I have it in not in order at all, and I printed that. And then what I did was I called the sort method on my new list, but it doesn't return anything. So what it does is it just sorts it in place, and it won't it doesn't give you anything back when you try and print it. So initially I tried to print my new list.sort, but it returns nothing. So it gave me a none. And so but what you have to do is then call it. So then you can print it below to actually see something. In this case with the Jupyter notebook, I just typed the variable again and gave me the output, but I can also do it this way, and you will see the same result. So I sorted it.
Tell me Christine's. Yes, I do. No, I didn't. Yes. You need to explain what's going on. Why did that officer trying?
Here we go. So John's asking, can this string be consolidated? So like print my new list.sort. Well, you can't print it, so you have to just sort it in place. Yes. So John, this isn't a string, it's a list of strings. So we gotta remember this isn't just one string now. But what we're doing is we're sorting it in order, and this kind of ties into Athena's question. So it goes all capitalized A to Z, then lower. Yes, because it does go in, the order of, what the characters are according to the ASCII tables. So if I were to actually, I can just open up the ASCII table so you can see. I think this will be a good one. Depends on. Let me make it bigger here. So you can just Google ASCII characters. But if you look here, you can see that, let's see, where's ASCII for characters? I think this is it right here. Okay, so when you're looking at this, the ASCII character for capital A is going to be a 65. And then it's gonna go all the way to Z, and then there's stuff in between, and then the lowercase a actually starts at 97 and then goes up to 122. So when you sort, the capital letters are going to go before the lowercase letters. Numbers are going to go before capital letters. So if I were to throw a number, but I'm going to make it a string. I think that was my mistake before. And if I run that, you see the 5 pops in the first index because it is a lower ASCII number than the letter characters. Does that make sense? Cool. So put that out of the way. And so this kind of shows, the power, like, of going into the documentation. Like whenever I was running this, I had problems like, oh wait, let me look at that again real quick. And I just went to the python.org docs and I Googled, sorting, Python sort, and this is what it gave me. And then I was just reading right here. I was like, oh, okay, I see what I did. I'm not supposed to print that because it returns nothing. I just then put it there. So sort is actually less convenient than sorted. So there's another method called sorted. I don't think we go over it here, but I think it's good to talk about because it actually does returns the sorted list for you, where you can then save it as a new variable, or it doesn't just change it in place. So if I were to print my new list dot sorted and then get rid of that. Hold on. My new list dot sorted. Yeah, sorted. Yeah, it's a new list. So if I were not to print it, why it's not showing up? I'll get back to that. That's I thought I've used it like that before, so we'll get back into that. Sorry about that. So again, you can use sort to sort it. You have to redefine it, or you have to sort it in place and then call it using the print function. So we have that. So we've gone over appending, we've gone over sort already. We've gone over like getting the length of a list in the same way you get a length of a string. Let's go over extend. So extend is a different way of adding items to a list when you want to add another iterable to a list. Lists are iterables, which means you can iterate over them. Same with strings. Strings are iterables. But if you use append is if you try to append another list to a list, it'll add that entire list as one single item to the list you're adding to. And if you want to kind of like combine lists into one big list, you don't want to use append for that reason. So if I have, let's go back to, my list here. And I want to append another list. If I run that, I'm going to get a list of just 6 items now because I had 5. And I'm going to get one more item, and it's going to be a sub list inside of that main list. But if that's not what I want to do, I would rather use extend. So I'm gonna run that again just to make sure it's back the way it was. And instead of append, I'm going to use extend. Oops, right there. And when I run that, now I get, actually I can just do length. My list is much longer, and it's actually every single item from that iterable added as an individual item to my list. If I run that, now I have 15 items in my list versus having, I would have had only 10. Any questions on those methods? So we've gone over append, extend, remove. They're pretty straightforward when you think about it. Sort is a bit different. Great. Let's keep moving on then. So let's go ahead and redefine. Let's redefine my list back the way it was. right, so we can do my list. Insert. We're going to insert my name at the index 3. Let's go ahead and make that a dot. That, there we go. Print it first so we can see what it was before, and then print it afterwards. Oh, come on. Did I get it backwards? May have gotten it backwards. I did. Whoops, let's flip it. That's what I meant to do. I meant to say index 3. There we go. Sweet. Now I can run it. All right, there we go. So now what I did was I inserted my name at the third index. So you have 0, 1, 2, 3, and then pushed everything else on. Just think about this whenever you're iterating over a list and you're wanting to like remove or add items when you're looping, that's really going to mess up how your loop runs. So if you're going to loop over this list, right, and you want to say, okay, well, if I get to make sure I insert the string Aaron, you know, if the type of the item I'm looping, if it's a set, you know, I want to insert Aaron at that index. When you do that, you're changing list in place, and then you're going to just iterate over that same item again. When you do that, because you're going to keep adding items to the list, you may get yourself into a situation where you have like a endless loop of adding like something in the index. Or if you remove an item, and if it's the last item in your list, you know, whenever you remove something in place in the middle of an iteration, Python's going to expect another iteration and all of a sudden not have something there, and it'll give you an error and say that, you know, your index is out of range, if you will, because your list changed in place. So remember, lists are able to be mutated, and they can be mutated in the middle of a for loop or something that's going to run over it. And you want to make sure that you don't do that, because you'll get some errors. You'll run into it when you're practicing some problems, I'm sure. Just know when you're doing it, you have to think about what's happening to the list as it's going on.
Hey, Aaron, quick question.
Yeah. Go ahead.
Well, append and extend, they're both going to be at the end of the list, but insert is going to be wherever we designate within the list, and it can also be another list, correct? It doesn't necessarily have to be like, you know, just, you know, we can also insert another list, and we can also choose exactly where, but whereas append and extend, they're limited to only the end of whatever list we're working on.
Yeah, so extend and append are going to be at the end, yes, but you can add, you know, you could add whatever you need to add in there. So let me just run that. You see, I've added another list inside of my list. I just designated what it was here. So with insert, you can designate whatever data type you want to be inserted into a list.
Understood. Thank you.
Yep.
If you took away the brackets and it was no longer a list, would it just be individual items that started getting inserted at the third index?
Yeah, but the thing is, I think it only accepts 2 arguments. It's going to be what index you want to insert, and then, you know, the one thing. This is 2 things now. So this will be like 3 arguments, this insert method. That wouldn't work. If I ran that, I get an error because it expected 2 arguments. We got 3. And this is 1, 2, 3. Because remember, insert is a function or a method. And how it's written the code behind the scenes is it's expecting just a couple arguments, and I just give it 3. So you have to, it has to be one item. Now it can be any data type. So your data type may contain several items, but it needs to be enclosed in either like, you know, a tuple or a dictionary or a list or something, but just be one item.
So if you wanted to add more than one like individual item, like single character, would the list extend the iterable? That wouldn't be the method that you're looking to use?
Oh, you're talking about well, if you can't extend in the middle, you'd have to extend at the end of it. So remember, the extend adds things to the last part. So you can use extend to add a bunch of things, but it'd be at the end. But if you want to insert something in the middle, then you would have to you could use a loop to do it. I mean, you could use a loop to add something at index 3 over and over again. If you want to. Yeah. And
Okay.
so it'll just push everything to the right as you're inserting items into it. So you would loop over what you're adding into a list, and then you would, you know, inside of that loop, you would just say, you know, whatever you're looping over, or your main list, you're going to insert, you know, the whatever you're looping over, whatever item is selected during that loop, and you'll just insert that item, you know, at index 3, and you'll add it in. So you could use a loop to kind of do this same kind of functionality with extend in the middle of a list, but it's not as clear cut. So you'd have to use a loop.
Thank you.
You're welcome. Okay, so let's go ahead and take a look at what my list looks like right now. Okay, so it looks like I have quite a few items in here. Let's go ahead and append. Let's add a few more errands in there. So play that once, play it twice, play it 3 times. And so now if I take a look at, and I'm going to go ahead and comment this out. So I can run that. If you look now, I have my name. It happens, you know, 4 times in this listing. And I want to remove I want to remove I want to remove one of them, right? I can run the remove function or remove method. Let's go ahead and print it up here as well. So when the first time I printed it, I had my name in there 4 times, and that was in memory. And then I used the remove method and I removed my name, but that removes it at the first position it sees it at. So you may have it multiple times, but you would have to run .remove several times to remove all of the, you know, entries. If you're looking at extra entries, you want to get rid of them. That's how you would do it. You have to run that over and over and over again if you have more than one occurrence. So the remove does remove the first item with that specific value. Any questions on that?
Yeah, so the question, Aaron, would we be able to, I guess, maybe multiply Aaron by 4 so that it can remove it 4 times?
I don't think so, because I mean, if I did that here, it would still be one argument. But when you do this right here, you know, let me go ahead and comment this out first so you can kind of see it. Actually, let's comment everything out and I'll just show that real quick. So I'm going to comment everything out, and then I'm going to do when I do that, if I run this, it's going to give me Aaron all together. So when you do a multiplication, you know, or what you think is multiplication is really kind of concatenating over and over again. It's taking that item, just concatenating it 4 times. So if I were to do that, if I were to do like a ×4 there, then it would not find that because it would think it's looking for then my name 4 times in this example. So that would
Okay, got it.
that'd be
Got it,
another
thank you.
instance. That'd be another instance where you want to use a loop to remove it if you know it's going to happen more times. But even then, you would probably have to still have an if statement in there. Like, if my item on loop, because you're going to loop over the collection. So in your collection, every iteration you have an item, and that item, you're going to look at it and you want to see if it is. And if you remove it, you're going to mess up your loop too. So you have to think about that. Like, how am I going to remove items in there? If I'm looping over it. And there's another way to go about that. So you don't have to use a for loop to check it. You can also check for membership in the list. So you can say, hey, if Aaron in the list, you can just remove Aaron. And then you can use like a while loop, for example, or something just to, while Aaron in list, remove Aaron. You can remove all the Aarons from the list. And so you have that ability as well. Okay, let's keep going here. Let's take a look at my list now. Run that. Okay, so I still have lots of Aarons in there. We can also pop. So the pop function, the pop method will remove an item at a given position in the list. If I do pop, and I do a -1, and I believe it actually returns it too. But I will go ahead and just call my list. If I run that, if you notice, I took off one of the Aarons in there. If I run this again, it'll remove another one. If I remove it again, it removes another one. If I do it again, it's going to remove the 3.3. It's going to keep removing at whatever index I specify. And I believe it just removes the end index, like the last index, if you don't give it an argument. So you can just run mylist.pop and it'll pop the last item off of the list. Ooh, good question. So Athena asked, does pop work with strings? And the answer I'm going to give is no, because what's the difference between strings and lists?
Strings are immutable.
Yep, strings are immutable, so you cannot use the pop method on a string because you can't change them in place. You can change lists in place. So that immutability is important. Just remember, like, strings are immutable, like integers are immutable, because they're also, the static data type. And you have tuples. Tuples are immutable, so you can't just change them in place. Oop. I can run that. Let's do our parentheses. There we go. So the clear method will just remove all the items from the list. You can use that. Clear is a pretty good method to use in a loop if you're needing to clear something in between iterations. So let's say you're trying to iterate and do kind of like an intermediate function inside of something and to create like a small sublist, and then get the results of that small sublist and add to a bigger list. And then, you know, when the next iteration happens, you may want to clear that list out to use the empty list to then start adding stuff to it. So kind of like an intermediate data type, like a holding data type to do something with. You can use clear to kind of help keep things neat and orderly between your loops. So that's one of the benefits of using clear. There's other benefits as well, but it just helps you remove items from a list and just turn it back into an empty list.
Hey, Aaron, quick
Yeah.
question.
Sure.
Let's say we accidentally, maybe we fat fingered one of the methods and we didn't mean to clear it, or we didn't mean to pop it, or we didn't mean to remove it. Is there a way to, I guess, return the list before we popped it, before we cleared it? Within is there like a method in place for that?
Not really. I mean, you're always going to have your starting point. So when you write a script, right, you're going to have some sort of starting point. And if you're writing a script that will like remove things from a list that you're getting in, like you could always go back to your start and like figure out what went wrong. So, I mean, all these things are changing the list in place and it's saving it. So it's saving in memory. There's no like undo when these run. Just like when you clear like a dictionary, anything else, those are basically very final. But
Oh,
I mean,
Jesus, okay.
yeah, I mean, that's just the way it is. So, that's actually a really good point. When we're thinking about like we're writing code, you'll hear people say like, hey, like you're doing stuff, like it's final, that's it. Like there's no like, are you sure you want to do this? I mean, it is, but we have safeguards in place, especially in like software engineering, when we have like a code base, right? Or we have a database, we typically don't touch production databases or production code directly. So we have like copies of it that are running in parallel that we change to see how it's going to behave. And then once we've done our testing, this is all stuff you'll get in, if you get into Code Platoon, you're actually in Whiskey Platoon, they'll talk about all this, but it's just having safeguards in place where you're not doing direct database operations or changing something with delete where there's no like, are you sure type prompts. There's ways around it. When you're writing a script, you're working with stuff in your RAM. So it's not really like your long-term memory unless you're using the Python, methods to do that. Like, like with open or something, which is one of those ways you can like create files on your operating system. You're just working with stuff you've declared in RAM. So when you're working with your RAM, it's kind of stuff that's already in flux and being changed. And so that's, I mean, while yes, these operations are final, I mean, they're final as long as the program is running. If your program doesn't touch any like long-term storage, there's really no threat. You can always just restart. So kind of like a video game, I guess. If you die in the video game, you just restart. It's a same thing. You're going to practice running a script, and then you'll make a mistake. You'll do something different. You get the result you don't like. You'll just redo it and just keep doing that until you get the right result. So it's not as scary as it sounds when we're like, yeah, it's final. That's it. So I wouldn't worry.
Understood.
And yes, it's always good to have backups. Have good, have a copy of something you're working on. But when you're working on a code base, we already have the safeguards in place, like Git and other things that kind of keep versions alive. So you can always back up your work or go back to a different version if you need to. Oh, so Jordan's asking, I meant, would my list at the index of 3 dot extend 1, 2, 3, 4 work? Oh, okay, well, let's try it out. Let me redefine my list because it's empty right now. So let's go ahead and redefine it. We can go back down here. Whoop, went too far. Let me make sure it looks good. Okay, yep, we got my list the way it was. So you're saying my list like this, 3. Like that? Well, if you think about it right now as written, we're not really operating this. There's a couple things going wrong here. So I can run this, but I'm going to get an error. So if you take a look here, we have this attribute error here, and it says set object has no attribute extend. The reason it's saying set object is because whatever's at index 3 is a set. So if I look 0, 1, 2, 3, because this is my list, that is a set. And so when I say, hey, I want to do you put your my list and you put your index in here, you're saying dot extend. You're saying, hey, this is a method that I want to run on this one thing inside of my list. So that's the first problem that wouldn't work, because that's the first error I got. But let's just say, okay, well, I just want to do it this way. Because now if you look at turn green, you see how it turned green? Because now I'm actually using the correct method for the correct data type. I'm now working on a list. And lists have their own method, and extend is one of those methods. But here, now I have 4 items in here. So if I ran this, extend only takes 1 argument. So yeah, you can't really put this in here. Now I can go ahead and do this. So I can extend it, and then I can make this 1 item. So now this is 1 item. What data type is this now that I've just illustrated?
Another list.
It's a tuple.
Oh,
Yeah. So tuple, because it has the regular, see those regular parentheses? Though that
okay.
signifies the parentheses and the commas tells me it's a tuple. But I could make it another list. I can make it a list of 4 items there. And now if I call my list, my 1, 2, 3, 4 have been added there. Because now I turned it into an iterable. This is an iterable. It's a list that I can iterate over, and that's exactly what it's doing behind the scenes. It's iterating over it. Daniel asks, can you chain more than 1 method together in the same line of code? So append and pop in the same line. I think we should go ahead and try. Like that. Nope, doesn't look like it. It doesn't like doing that way. So you just need to have another line of code and run it again, because you want to make sure that this dot is coming off of a list. That's one thing I encourage you to do. If you have questions like that, always ask, like just like Daniel did. But if you have your IDE in front of you, if you're working on Jupyter Notebook, or you're working in Replit, or on, if you're already in VS Code, coding away, just try these things. It doesn't hurt to try and see these errors, because the more you're exposed to these errors, the more you'll understand them and kind of understand what's going on, and where's my error and how can I fix it. When you see these often, you kind of understand, okay, I know what this means and I know where I can fix it. So it becomes easier and easier. All right. I think we're at the top of the hour. Let's go ahead and take a 10-minute break. Make it a 12-minute break. Come back at 7:10, and then we'll resume these list methods, and then go into some other things with lists, and then we'll finish up with tuples. Okay. All right, welcome back, everybody. We're going to resume, kind of go over these list methods that we'll use. Before the break, we really went over, appending, extending, inserting, removing items, and then like using pop, or even just clearing a list. We have this another method here called index, and what that does is, if we want to look for something, instead of removing it, we could just remove it. But what if we want to find where in the list we have an item? We can use index to find the first item with that specific value. So if you have multiples of the same item, you're not going to get all of them, but you will get the first occurrence of it, and at least you'll know it's in there. So with that, let me append some items to my list. And let's go ahead and just add more of my name in there. And I'll just run this a few times. Okay. And now my list, let's see, my list dot index. And from that, I found my first one at index 13. I'll go ahead and let me print it because I want it to be horizontal. All right. I run that. So the first time my name occurs is on index 13. So we can do it there. Index 13 or index -4, because it's at the starting from the end, you have -1, 2, 3, and 4. I know there's a way to get that to show up. I just see how do I do that? Trying to remember how I get that -4 to show up. I'll think of it, and I'll show you that trick as well to get negative indexing. But that's what that does. It only shows the first occurrence, so it will not show the other occurrences unless you start removing them or doing some other action, but at least it's in there. Conversely, you can use count. I can run that. And I can go ahead and I think I can print it. Yeah, so if I print my list.count, I can see I have Aaron in there 4 times. That's another way to kind of identify, if you need a certain item in a list, you can use the count function to get that, or the count method. We went over sort already. I did go back and messed with sorting to show the difference between sort and sorted. Sorted is typically what we use nowadays versus sort. But what you do is you'll define a new variable, you'll assign it as sorted, and then as a parameter, you put in the list you're wanting to sort. And when you do that, you get returned your new list. And so your sorted list, it becomes a new variable. So it returns something. So I print the starting list, and then I went ahead and defined a new variable called my sorted list. And then I sorted my new list in place, and I printed both of them to show that they both are the same, but it's also different because it's a new list. It's not the same list. Okay, let's go ahead and let's do my list dot clear. And then my list dot extend. We'll do it that way. So what I'm going to do here is I'm going to print it. I'm going to print the actual list. I'm going to clear it. And then I'm going to extend my empty list with this new iterable of 1, 2, 3, 4, 5. And then I'm going to go ahead and display it. So if I run that, I printed it. I printed the count. Here's the entire list. And then I cleared it. And then I extended it. Now this is what my list consists of. This is the new value for my list. Okay, so now I'm going to do the same thing, except I'm going to reverse the list and then display it. And so what reverse does, this is the next method here, it reverses the elements of the list in place. So it'll stay that way as well. So you're actually permanently changing your list to be in reverse order at that time. Any questions on the reverse method? It's a pretty powerful method. A lot of times you'll get coding challenges where it'll say like, reverse this list of items, and like they want you to like go through and loop through them and kind of change their place and do it very long and complicated, where you can just run list.reverse and it will just do it for you behind the scenes. You don't have to worry about running through, but it's still a good thought exercise to try and do it without using these methods. So you can do everything these methods do and write your own code, but this is just much easier for you to do it. This last method, the dot copy, returns a shallow copy of the list. And what I mean by a shallow copy is, so I'm going to do the copied list equals my list dot copy. And let's go ahead and let's just get rid of some of these. All right. So I'm going to show you kind of what we mean by shallow copy, because I think that's an important concept for you to understand. Even though the effects of shallow copying probably won't affect you, it could if you're making lots of variables to hold data and then you copy one of them, you could inadvertently make some big mistakes and you won't understand what's going on. So I wanted to show you what happens when you make a shallow copy. So it was my list. We'll go ahead and print it real quick so we have it. So print my list. And then I have the copied list. So I'm going to print the copied list. Okay. And then I'm going to change my list. So I'm going to add an element. Well, I'm going to redefine the second element in my list to be my name. So if you remember what my list was, I can go ahead and run this so we can see it's 5, 4, 3, 2, 1. So I'm going to print it again here, and then I'm going to make a new variable called the copied list, and I'm going to run the copy method on it. It should define it to the copied list. And then I'm going to print the copied list. So in fact, I'm going to go ahead and clarify that. There. So you'll be able to see that. I'm going to change my list. So I'm going to go back to my list and change the second element to, or the third element to my name. And then I'm going to print it, the copied list again. Okay. Let's see here. Oh, so it is not my list. Let's go ahead and print my list real quick. I'm going to reset my list. Okay. And copy the list. Reset it and do it again here. I believe I have this right. So let's see what's happening here. My list, copy. We're printing the copied list. We're printing my list. We're changing it in place. So it is not. Okay, that's good. That is really good. Okay, so I was a bit off with that. But I can show you what happens when you do change a list. So this will actually create a separate copy that will not be changed. But if you were to do, let's redefine my list here, equals 1, 2, 3, 4, 5. And say new list equals my list. And I were to print new list. I would get the new list will equal my list. But if I were to change an element in my list, and we'll do it 2 again. I believe this is what happens. Yeah. Okay. So the difference between doing a copy and then doing like an assignment. So you may think that this right here is making a copy of a list that you define. So in this case, I'm defining a list as 1, 2, 3, 4, 5. And then I'm saying, hey, I want a new list to equal what my list is for now. And I'm printing my new list. So I did right here. This is where I printed my new list. And then I went back to my list, the index of 2, and changed it to my name. But I didn't print this one again. I just printed that same one I printed before, and it changed because this did not actually create what's called a separate copy. It's a pointer to the other list. So it really kind of mirrors it. You may find yourself in that position where you'll do that. You'll want a copy of your list. And so you say, well, I just have my new one is going to equal it for now. And if I change it, the other one won't change. That's not the case. The new one will change too, because it's just pointing to the memory locations that you had designated as my list. The copy will actually create a copy that will not change. And so that's what I was illustrating here. So here I made a copy and then I changed my initial list, and the copied list did not get changed like my list did. And so that's the difference between those two. And the one is you're assigning a new variable to equal whatever this list is, but it's not actually completely separate from it. So if you change the original list, it will change the new one too if you try and assign it that way. So that's just, I wanted to illustrate that point because that can get you in a pickle when you're writing code and you're trying to, take a shortcut by, making one list equal another. But that's what the copy function or the copy method can help you with that, where you can actually create a separate copy. We talked about slicing with strings last lesson, where we were able to extract elements from a subset of elements from a string. You can do the same thing with a list. So if I have my list and I were to go, I want to start at the beginning and just go to the up to but not including the second element and run that, I'm going to get back just 1, 2. So I'm just going to get back the zero index, the first index. I'm going up to the third index or index number 2, but I'm not including it. So it's up to but not including. So that's the list slicing. And I covered that pretty in depth with strings. It works exactly the same with lists for the most part. It's, you can slice lists just like you can slice strings. Just you got to keep in mind your elements may be complete data types, but they're still treated as one entry in the list. Any questions on that? This last entry for lists is list comprehension, and it's a short, concise way to create new lists based on existing lists. In this case, we have our number list here, and then our squared numbers. We're saying that we want to, again, this mathematical operator, which we learned in the first lesson, that's going to square whatever number it is. And we're saying we want to go ahead and square x for x in numbers. So we're going to basically kind of loop over this numbers list, and then we're going to return that this little function or this little mathematical operation for each number. So x will become 1, and it's going to iterate over. So it'll be 1, then 2, then 3, then 4, then 5. And if I run that, you can see it 1 times, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. I don't necessarily think you'll be needing to use list comprehensions, so I'm not going to really dive into the applications as much, but you can use it as a shorthand if you're trying to, make a new variable with an already existing list. And you can see the power of doing, a quick operation on, the numbers or whatever you have in your list. It could be a string and you're doing something with a string. So it's just a quick, concise way of doing that. And that covers really a lot of the methods we're going to use for lists. Are there any questions on lists in general over all we talked about? Okay. We're going to move to tuples, and tuples are immutable. And Tim says most important. What do you mean by that? Well, I covered a lot of stuff in the list because a lot of the methods will also apply to tuples, except for the ones that will like reorder it. So a lot of the methods I introduced for lists, some will apply to tuples, but because tuples are immutable, some of those methods won't apply. So it's not gonna be as in depth. But the way you can slice tuples, you can grab a certain index from a tuple. Lists are going to be used more often than tuples, so I wouldn't say they're the most important, but like of this lesson, lists are going to be more prevalent in code. But sometimes there's a need for tuples for sure, and they're going to be used for data types that typically you don't want to change. So stuff that stays static, such as coordinates, those are big. I come from the geospatial intelligence community, and so we work with coordinates quite a bit, and they are represented with tuples more often in code. It doesn't say we don't use lists for it, but a more secure way to make sure you have data integrity is to use a tuple if you're working with something that's just not going to change. So, but yeah, tuples are also ordered collections, just like lists. They're created using the parentheses, or you can use the tuple method. So I can go ahead and say my tuple equals tuple. My other tuple equals like that. Tuple, run that, class tuple, and then other tuple. It's also, so I print both my tuple and my other tuple, and they're both class tuple. So you can create them either way. Most of the time, unless, with a tuple, you're not going to be appending data to it. So you're not going to be creating empty tuples unless you're, going to be redefining them with something. If you already have the data, of course, you can put your data in, and this would be a tuple with actual stuff in it. So numbers or letters or lists or anything. So you can have mutable data types inside of a tuple that you can change, but you can't change the tuple itself. Let's explore that actually. So we have, oops, let's do 5. Let's just put a list in here. So I'm going to go ahead and print my other tuple. And then I'm going to change. So I'm going to say my other tuple, the index of -1, dot append 4, already 2, 3, 4. So let's append 5. Print. So what I'm doing here is I'm designating my other tuple as 3, 4, 5, and then inside of that tuple, I have a list. I'm going to print it to bring it out to the console, and then I'm going to go ahead and try to access the last index in my other tuple, and then append a 5 to this sublist, and then print it. If you look, I can do that. So that lies a question, you know, tuples are immutable, but are they really immutable? Because I changed the last index of this tuple. So in one sense, I didn't change the tuple because I didn't change the length. I didn't change anything. It's still 4 items. But one of the items inside, which is mutable, was changed. Yes. So when you see here, the data type inside the tuple can be mutable because it is a mutable data type. So we can't run like extend or append to the tuple itself, but we can run append on an index in the tuple. So the tuple is the container that can't change. It still has only 4 slots, but we can change the stuff inside. So that's just something to think about where, you know, it's just kind of, it can be a bit confusing when we talk about immutability, but the tuple itself never changed. It was still just 4 elements. So it's just the one thing inside. Just like with lists, we can check the length of a tuple by running length. So if I run len my other tuple, if I run that, I'm going to get back a 4. So I ran length and I got that back as a 4. You can also check for membership. So if I want to see if the number 5 is in my other tuple, just like you have in your example here under common tuple operations, this is a Boolean statement. So it's 5 in coordinates. If I ran that, of course, it would become false because coordinates does not have the integer 5. If I ran 5 in my other tuple over here, I'll get back a true because it is in there. So if I did 5 in my other tuple and I ran that, I'll get a true.
Hey, Aaron, quick question.
Yeah.
For that, what you just did, is it getting the 5? Is it saying it's true because of the first 5 or because of both 5s that are within your other tuple?
But that's a good question. So let's go ahead and redefine. Let's just redefine it like this. So now I'm going to just not have a 5 in my tuple. So I'm going to run that. And now I said 5 in my other tuple. It's false, but it's there, but it's not in the tuple. It's in the list that's inside the tuple. So when you say in, when you say, 5 in my other tuple, it's not going to check a sub data type inside of an index for that. You would have to go check that yourself.
Okay, got it.
Yep. So Athena, he just asked, does 5 in my other tuple, is it checking for the 5 that was inside the list? Because it is in there. And that's what he was asking, and it does not. Okay, you can also use the count. So an index, just like we did with lists, you can use the index method to find the index of a value that you're looking for. Same with count, it'll return how many times it's occurred. So if I had several 4s in my other tuple and I ran the count method on that, I would get back however many times that 4 occurs. It would not, again, it would not drill down to the sub data types. So if I were to run my other tuple dot count 4, if I ran this, I think I'll get back just a 1. And I did, because it's only looking at the data types as a whole. This is a whole data type. That's not a 4. This is a list containing a 4, but it's not going to dive into that list and look for that. Okay, let me see what they're saying here. We're saying tuple unpacking. Okay, I see what this is saying. So I can then Command C. This is unpacking values. I think that's what we're saying. Yep. Okay. So what we're doing here, this is what's called, it's called tuple unpacking. And we're saying, hey, we have a tuple and its name is coordinates and the tuple is 3, 4. When we flip this around, what we're saying is, hey, we have X and Y that we want to define, and we want to define them as coordinates. So what's going to happen is if you know how many items are in your tuple, you can designate a bunch of items beforehand, and then it will just go ahead and assign each one in order to your coordinates. And so what I did here is after I ran x, y equals coordinates, I printed x, and x is 3 and y is 4. And that shows that it's unpacking it and then assigning it to x and y. I don't think you won't need to use this tuple unpacking. You could, I mean, it could help you organize your data. But for the exercises here, I don't think we'll need to use that. So in short, I mean, the tuples really, they aren't much different from lists. When you all these methods we learned in the beginning of the lesson, a lot of them can be used for a tuple, but some can't because they change a list in place, and you can't change a tuple in place. So just keep those in mind. You couldn't use append or extend, remove. Those things act on individual elements of a list, and you can't use those for tuples. But some of the others like length and index and count, you can use those methods on your tuples because you're not actually changing the data. So that's the end of the lesson, going over tuples and lists. We went over quite a bit. We went over about 45 minutes, so an hour and 45 minutes, or 35 minutes of lecture. I think that's pretty good. Any questions over this before we start looking at the assignments? And then when we finish going over the assignments, we can then, open it up to questions on the previous assignments that we had when we're going over strings and so forth. But we'll still be active until 9 o'clock tonight. So are there any questions right now over the lesson today? Or anything that wasn't quite clear and you may need illustrated another way? Okay. We can move into the lessons or to the exercises. We have 3 of them here. I have already opened them. I just got to find them again. least I thought I did. Yeah, here it is. I'm gonna make this a little expand a little bit so it's easier to read. Okay, in the first one we have doubles, and it's you'll be given a list consisting of unique elements except for one thing that appears twice. Your task is to output a list of everything in between both occurrences of this element in the list. So in this case, we have, in this first example, we have 0, 1, 2, 3, 4, 5, 6, and then we have a 1 again. So we have two 1s here. Again, only one of them will be the same. And then we want to go ahead and extract out everything in between those 1s. So that's going to be the result of our function. So just thinking about, functions and how we construct them and what we need to do. Again, this pass is just there, so there's no errors in the code when they created it. So you can run this code as is. I think I can run it, and I just get falses, right? So it allows you to run the code, but I don't know. Let me refresh it so I can get back to what the code looks like. And I'm waiting on it. Goodness. There we go. So you can just run, so that passes there just so you can run that and see that you'll have failing tests. So you can just replace this pass after you fork it with whatever code you need to put in there. So it looks like it's using different data types. It's using some Booleans, it's using strings, it's using numbers, and you just want to return what's in between. If there's nothing in between, you'll want to return an empty list. And so that's what looks like that's what this is showing. So it looks like they just need to actually throw a print statement in here. But here, if you're given a 0, 0, and that's your input for your list, well, you have your two inputs, but you have nothing in between, so you want to return an empty list. Any ideas of how you would tackle it? Anybody have any ideas of how they would tackle that one? What tools they've learned so far that they would use?
My first instinct would probably be the count function and go through and like loop through and count, and then if it equals greater than 1 and somehow find an index. I don't know. I'd have
You started spitting out the methods we just learned about. So yeah, I think you're, you want to, I think you're on the right track. You want to look for, something that occurs more than once. Maybe that's iterating over the list. So Nika, put that out there, iterate. So maybe do a loop over the list and see, if you have something repeating. Yeah, that's yeah, maybe you could do you can loop over it, so over each item, and then maybe run a count on each of the items. And when you see a count equal 2, you found your right item, and maybe you want to stop your loop there, or just maybe save that one into a special variable that you can reference later after the loop or something. Yeah, that's a good one. Okay. Moving on to the next one here, we have a pretty long description here. I'll let you guys read that one. Okay, so it has 2 arguments. So it looks like it's having this write a function that has 2 arguments. cities visited, so it's something she's visited before. Cities offered will be ordered in terms of the relevance of the conferences for Lucy's research. So from the most to least relevant. Okay. There's a lot going on here. So what it's saying is you're given a list of where Lucy has been, and then where they're being offered. So sometimes where she has been will be in the offers, and you don't want to go to those. So if where she's been is all of the different lists, you want to return no worthwhile conferences this year. Okay. Yeah, that one looks like a good one. And then the ones they're being offered, so the cities offered for the conferences here are ordered in so most relevant to her research. So if she had never been, since she's never been anywhere in this example, Lucy has never been anywhere, and she's being offered Philadelphia, Osaka, Tokyo, Melbourne. She wants to go to Philadelphia because that's most applicable to research. I would want to go to Osaka or Tokyo, but okay. And so it looks like a couple of these, if you kind of read these, you can say, okay, well, in these three examples, she's never been anywhere. So I just want to return the one that's first in the list, it looks like. But then now she's been to several places, and I need to somehow keep those in mind and then think about where is being offered. In this one, there's no, she's been to both those places, so we don't want to go. And then in this one here, the same thing. It looks like Stockholm, Berlin, and Chicago are all in that places she's been. And then we have a bunch of fake city names down here. So now, like, some of them match where she's been, and so you need to pick the right one. So in order. So this one, in this case, we need to pick Mega Tokyo. Okay. Yeah, I would go to Melbourne. I've never been to Australia. I lived in Guam that was one of my final assignments for 4 years, and I never made it to Australia because the cost of going to Australia from Guam was the exact same as flying to Australia from the States. And so I was like, no, I'll just go to all other places in Southeast Asia for like $400. So I was able to visit a bunch of Southeast Asian areas from Guam. It was nice. Okay, let's take a look at this last one here. So a few of you have been to Guam. Yeah, I loved it. It was my favorite assignment. The Museum of Incredible Dull Things. So it looks like here they want to get rid of some exhibitions. They want to remove the most boring. She gives them a rating and then removes the one with the lowest rating. Okay. Just as she finished rating, she's off to an important fair, so she asks you to write a program that tells her the ratings of the items after one removed the lowest one. Fair enough. Okay, give an array, remove the smallest value. Do not mutate the original array list. If there are multiple elements, same value, remove the one with a lower index. If you get an empty array or list, return the empty array or list. Okay. Okay. So what they're having you do is you have a list and they may not be in order, and you don't want to mess with the order, but you still want to get rid of the lowest value in the list. So you're going to have to somehow find where it is. And then if you have multiples, okay, so you have multiple low values, so these are all 1, 1, 1, you need to remove the one with the lower index. So, okay. There we go. So already you're starting to think about how to use that shallow copy. Yeah, I'm going to look at the terminology in that, in that lesson. Because I normally think shallow copy is one that actually mutates the original list, but I could be wrong. But anyway, those are the assignments. So these look pretty good. Are there any assignments that we want to go over? I think it was Daniel, right? You asked the DNA one. Okay, we can go over that. Let's see here. Did you want to share what you have already, or did you even make progress? It's okay if you didn't. I just, even if your code's incomplete, I like to still like run what someone has. Okay, so you don't have any progress. Okay. Well, here on my screen, I went ahead and quickly did a solution. And so the premise of the problem, if I know a couple of you did not attend yesterday's session, you're looking for DNA sequences and you're looking for specific portions of DNA. I can't remember the names of them, but we'll just say G and C what you're looking for. And so what I did, and I'm going to get rid of this first, actually. I'm going to go ahead and just comment this part out. What I did initially was I was like, okay, well, I need to make an empty list so I have a place to put G's and C's when I find them. So I'm just going to put that there. And then I want to make another list that have the targets I need. And you don't have to do it this way. This is just my solution, but I made a list called targets. I could even make a tuple so they don't get changed, but I'm not changing anyway. But I could say, okay, I have a list with G and C in there. And then I'm like, okay, well, I want to go ahead and loop over the string that I have. So I would get a string maybe like this, or one that has, 1,000 items long. It doesn't really matter. I'm just, right now getting a string and I'm going to loop over it. And for every item, I'm doing an if statement. I'm saying, hey, if the item is in target, so I'm doing that. Remember that using the in statement for in our list lesson today. I'm using that method to do this. You didn't have to use this method, but that's what I'm using. So I'm saying, hey, if my item is either a G or a C at that point, because if it's in targets, either a G or a C, I'm going to append it to my GC list, and I'm going to keep it. I'm going to go through every single item in that string and just append those G's and C's to this list. And then I just do a mean calculation at the end. So I say, okay, cool. Now I have my GC list and I also have my string. So I'm just going to take the length of my GC list and I'm going to divide it by the length of the string, which is how you find, not mean, but percentages. And then I'm going to multiply that by 100. This division operation is going to turn those two integers into a float, and I'm going to multiply by 100. It's still going to be a float. So it will match the result here, and I'm going to return it. And so that will work, but I run into a problem here when I run it, and I see I have a 0 division error. And that's because I have an empty string initially. And that means I'm going to try and divide by 0 here, and you can't do that in math. So I added a condition at the very beginning of my function to just do a check for zeros. So if my length of my string equals 0, well, then I know I can return a 0 because none of them are going to be G's or C's. And so if I run that, then I get all my trues in here because my GC content, what it returns, the result matches, or the result ends up with the percentage calculation ends up correct by comparing the length of those. But I can do it another way, so I don't even need this. And I can say if item equals G or item equals C. this should give me the same result, and it does. So again, using that in method or the check for membership of a list, that's the initial way I did it. Or you can just write a longer if statement and have an or conditional in there, so you can have it either equal G or C, and then do this logic underneath. You can do it both ways. Does that make sense, Daniel? There is a lot going on. It's a lot to unpack, but again, this is remember that GC content here. You're right, Athena. You're gonna make it really complicated initially. You're gonna have all these variables. I made like tons of variables when I first started out, and I was like, I think I need to save this as something, and I can work with it later. But I was running out of names for variables, and it was hard. But this programmatic thinking, really, when you start thinking programmatically, it gets easier and easier as you go forth. So you're saying, do I need that first def line? Well, that's in the original lesson. I think I have it actually up here. I just copied it over to my Jupyter notebook. So you're talking about this line right here. So this was the original problem, the def. That's defining the function. So if you remember from the functions lesson, how you define a function in Python is the word def. When you write that, Python knows, okay, I'm about to get a function named, and that's the name of the function. The name of the function is GC content. And then you open and close these parentheses, and you have a parameter in here. In this case, this function is requiring us to pass in one parameter or argument, which this is what's happening here. We're calling the function here. The first time we call it, we're saying, hey, I'm passing in an empty string as a parameter. And so that's what's going to go in. Now, right now, we're just passing. So if I were to run this function as is, we're going to get a bunch of falses because it's going to see the function be defined. The only thing that function doing is just nothing. It's just passing. And then we're going to go down to line 16. And this is where Python's going to start executing code. And it's going to say, hey, print the result of whatever returns from this function and compare that result to 0. Okay, well, what's the result of GC content? Well, it's going to be nothing. So it's going to say, does none equal 0? And that's going to be false. And then next time, we're going to go in, we're going to pass it an A. It's going to do nothing. So the result's going to be none. Does none equal 0? False. So on and so forth, all the way down. So it's going to do that over and over again. It's going to print 5 lines. So if I run this, it'll take a minute. It's going to give me a bunch of falses. And that's what happened. So the initial staging of that problem, the def line is there because you're defined, the function's already defined for you. It's kind of a starting point for you. So I just copied that over, then I took the pass out and I replaced it with my own logic. So this is all the logic that happens underneath the function. So now when I pass an empty string, so the str equals empty string once the function starts to run on this line. And then it's going to go, hey, if the length of my empty string is 0, which it is, I want to return that. So this is the return of that logic for this one. And I returned 0.0. So the return of this function, which is 0.0, does that equal 0.0? Yes, that's true. And so that's where that happens. On the next one, str is defined as the capital A. So it's going to take a look. Well, is my length of my string, which is 1 character now, so does 1 equal 0? No. So it's not going to look at this line. So it's going to pass by that line because that this if statement evaluated to false. And then it's going to say, okay, cool. Well, now I want to define a new variable called GC list, and it's going to be an empty list. I could also do this. I can do that too. Either way, both of those are the same exact statement. And then I'll leave this commented out, and then I run into the for loop. So if I have a character in here, it's going to run through all the logic. If I have no character, it's just going to return the 0.0. Does that make sense, Daniel? It's a lot to unpack, and it's okay. Well, you have time. You definitely have time, and with practice, doing these exercises will help you kind of get to that mindset of programmatic thinking and how functions work. When the whole point of writing a function is to write something that's reusable, right? Do I reuse it in this whole code base? Yes, I do. I reuse it 5 times. I use it once here. So I call that function here once, and then I call it again, and then I call it again. And the only thing I'm changing is my parameter. So every time this function runs with these calls, this str gets changed to empty string, A, C, CA, and then A, T, 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 C, C, all these ones. So every time it's doing that, it's changing it. So when your parameter changes, then this for loop, how many times it iterates changes, depending on what string is. So that's the point of functions. All right, let me see if I can stop recording now.